Now, a theory that falls in sort of the same camp as global workspace theory in that it posits higher cognitive functions, like in global workspace, attention, for example, is to be crucial for consciousness, is a category actually of theories which are called higher order thought theories. In higher order thought theories, there is a clear distinction between what are called first order representations and higher order representations. Now, what are first order representations? First order representations are just, the representations in, say, sensory cortices, but also like memory regions or your emotional arousal circuits and well, stuff like that, which process, well, information, you could say, from the outside world. Either visual, sensory, auditory, etc., but also like the things you memorize. Things are stored in memory, but stimuli may evoke some sort of arousal, positive, negative emotions. So these are all considered first order representations. And the critical idea of a higher order thought theory is that as long as they stay as such, they are unconscious. Only when these first order representations are re-represented by higher order regions, and in this version published by Lau, Brown, and Rosenthal, these higher order representations typically sit in prefrontal cortex, then they become conscious, because these re-representations are what they consider thoughts about, and it's a very important term here, the first order representations. And so, for example, the perceptual representations are typically re-represented in dorsolateral prefrontal cortex, mnemonic and conceptual ones in frontal polar or ventrolateral prefrontal cortex. For other regions like body sensing circuits, arousal circuits, these are more processed in medial parts of frontal cortex, like ventromedial, anterior cingulate, orbital frontal cortex. And only these are enabling these higher order thoughts. Now, what exactly are these higher order thoughts? Well, for one thing, they are, as said, a re-representation. So, again, the first order representation is just a sensory or cognitive representation of the world, like, visual representation of, say, a red apple or something. And this carries information about some external reality. And this could be dry information in the sense of, just visual auditory information, but it could also be information about, say, the valence of a stimulus, whether someone is looking angry and what have you. But central to the thesis is that this first order representation then has to be linked. Yeah, you could say to some form of I, of myself, of a term that's also often used is inner awareness. And only when this linking occurs, you have a representation about a mental state, a representation of a mental state about that first order representation. And so, like, I am seeing an apple, and that makes the first order state then conscious. Now, of course, I am seeing an apple really is a thought in the sense of, thinking verbally. It doesn't have to be like that. In that sense, there are what are called heavy and lean versions of higher order thought theory. And so these higher order thoughts not necessarily imply that you really think verbally, okay, I see a red apple. It could also be, a somewhat non-conceptual, non-verbal re-representation of that seeing of an apple. But the crucial thing is that it's linked to some form of me, of some form of I. And there are different versions, as I said. So the classical version, as proposed by David Rosenthal, a philosopher who actually was the first to coin this whole idea, he considered this inner awareness sort of a basic state that you have when you wake up. So that's the sense of me, the sense of self, which he considered crucial for any type of conscious sensation, and only when stimuli are linked, first order representations are linked to this cognitive self-awareness, then they become conscious. And in his view, these higher order thoughts indeed are more or less literal, like indeed, I see an apple, thinking I see an apple, or at least conceptual. Now there are leaner versions. For example, a few mentioned here, where this thought is replaced with a non-conceptual version, more like a sensory-like monitoring system. An example of that would be a system which does reality monitoring. So, for example, when you see a stimulus in the outside world, of course you realize, yeah, that's real. That's the outside world. Whereas when you, for example, close your eyes and you imagine something, of course, some people can really vividly imagine things in their mind's eye. I can't, by the way, but some people can do this. Of course, yeah, you also know, in a sense, that this is not really out there in the outside world. Of course, this difference vanishes a bit when you consider cases like hallucination. But also in hallucination, of course, there are versions of hallucination where you have this very vivid percept, but you realize it's not real. It's not there in the outside world. So this kind of reality monitoring could be a form of such a, well, leaner version of higher order thoughts. So these more like sensory-like monitoring systems. So the higher order thought then is a kind of inner perception of the first order one. Admittedly, and you can also see this because many of these terms are within these parentheses, quotation marks. Admittedly it's often a bit vague, but I'll get you some more hands-on versions of it in a second. And then there is even an even leaner version of these higher order thoughts, called self-representation or same order models, where the first order actually is capable of a sort of self-representation, so that there's no separate higher order states required. So that would potentially not require prefrontal cortex level re-representation, but maybe a re-representation in, say, cortex itself, or somehow that consciousness is the representation plus some sort of implicit self-ascription, as it's called. Okay, so as said, I can imagine that this is all, a bit vague, which is in part, of course, also because it has this strong background and roots in philosophy rather than in cognitive science, psychology, or neuroscience. But as of lately, it has been taken up more strongly by, indeed, people from cognitive science, psychology, and neuroscience. So let's have a look at a few experiments which actually try to get a handle on these higher order thoughts. Now, one way of getting a more practical handle on this higher order thought business would be, for example, measuring what's called metacognition. And now, what is metacognition? Metacognition is, for example, in this task, we have to detect the stimulus. How sure are you about the response that you just gave at this detection task? So there's a stimulus being shown there, and then people have to detect the stimulus, so answer whether there was a stimulus, either yes or no. Of course, in other trials, there's no stimulus. And then, of course, they will get a certain percentage correct for this task. But they also have to, after doing this, give a confidence rating. So how confident are you that either the yes or the no answer you gave is right? And they can have a low confidence or a high confidence, of course. Another way of doing this, I think a very nice way actually, is what's called post-decision wagering. How much would you bet on being right? So that's putting your money where your mouth is, you could say. But either way, so then you can have trials where people have low confidence and then look at to what extent their detection was either correct or incorrect, and where people have high confidence and judge whether their answer was either right or wrong. So that's what you have here. There's 4 different confidence ratings that people could use. So either 1, 2, 3, or 4. And so what you have here is the percentage correct or incorrect answers for these different confidence ratings. And as you can see, in this situation, when there's low confidence, indeed, the answers that people gave were mostly incorrect. Whether when there was high confidence, answers were mostly correct. And And so this would be a situation where there is a good correlation between the confidence that people have and whether they were actually right in the answer that they gave. And this metacognitive capability is then considered, well, you could say evidence of people really being aware, not only of their detection, but of course then also of the stimulus that they saw. And this is two different examples where the relation, in this case, the relation between the confidence rating and the difference between correct and incorrect is very clear. Here it's a bit less clear. I mean, also with the high confidence, there's still quite a number of incorrects, and with the low confidence, there's still quite a number of corrects, or not that many incorrects. And you can express this difference in metacognition. So here there's really good metacognition. People really know whether they're correct or incorrect. Here there's somewhat weaker metacognition. You can express this as a meta d prime. So you just plot the probability of people being confident and while being incorrect versus the probability of people being confident while being correct. And the more this curve goes like this, the more it looks, you could say like this. And then as in standard signal detection theory, of course, the difference between this curve and the diagonal gives you meta d prime in this case. Of course, normally it would give you d prime like in a normal detection task, but here it gives you meta d prime. So that's a way of measuring the amount of metacognition that people have. And this is a very practical translation of this whole higher order thought business. How confident, for example, are you in the decisions you just make about a perceptual task? So you thought you saw it, so you pushed yes, but did you really saw it? So that's what the metacognition is then trying to get at, and that's a very practical example, I would say, of such a higher order thought. So this is an example of an experiment where they try to influence the amount of metacognition or higher order thoughts that people had by applying transcranial burst stimulation of the prefrontal cortex. So that's a way of, with electromagnetic fields, interfere with the activity that's ongoing, and in this case, prefrontal cortex, lateral prefrontal cortex. While people are doing such a task where they had to, in this case, detect whether a face was upright or upside down. And they did this with the method of constant stimuli, so that the percentage correct was always like somewhat in the order of 70% or so. And then at the same time measure their metacognitive awareness, in this case by asking, so after they had given a response, was the face upright or upside down, by asking how clear did you actually see that face? You could argue sort of a metacognitive awareness of the judgment that they just gave. Again, scaling 1, 2, 3, and 4. And what they observed is that indeed, if you apply TMS to lateral prefrontal cortex, this type 2 D prime, so metacognitive awareness D prime, goes down. What you can also, of course, do is calculate the difference between the meta D prime, so the D prime you get for this task compared to the D prime you have for this task. Now, ideally, this is sort of constant between the two situations because of this method of constant stimuli. But just to make sure of that, they subtracted it from the meta D prime, and then you see the same effect, which is that TBS to the transcranial burst stimulation to the lateral prefrontal cortex reduces this meta D prime relative to normal D prime relative to when you apply the TMS to a control region. A way to show that this metacognitive D prime is something which is specifically affected when you interfere with activity in these higher regions in prefrontal cortex. And this is another experiment showing how this meta D prime really relates to having conscious sensations or not. By Kolb and Brown in 1995. I have to say this is a paper that had been retracted later on because of some methodological issues and results issues that are not really relevant for the discussion here, so that's why I'm still showing it. But this experiment goes as follows. People are shown these kinds of stimuli and then slightly different in the left eye and right eye. So what you have here is these Gabor patches, which are either oriented like this or oriented like this in the two different eyes. And then in each of these eyes, there is this patch which has a different orientation of the Gabor patches. So here it's different from the surround, here it's different from the surround as well. But if you fuse these two images, what you will see is sort of crosses, because of course you combine these diagonals like this and like this into sort of a cross-like a Gabor patch. And the same will of course happen here as well. So the result of that is that you don't see these different these patches when you fuse the image. Of course, if you would close one eye, you would readily see that there's this patch over here. And also if you close the other eye, you would see that. But if you fuse the image by having two eyes open, you don't see them. Now, what they try to show here is what's called blindsided normal observers. And the whole point was that they argued that people could nevertheless, without consciously seeing these patches, still guess correctly whether the patch was either on this side or on this side or on this side or this side. Now, how did they try to show that? By measuring, again, confidence, the confidence rating they had for the guess that they had to make whether the stimulus was sitting over there or there or there or there. And this is then what you would get. So this is confidence ratings, in this case going from 1 to 10. And this is percentage correct for the non-rivalrous case versus the rivalrous case. Now, what I just explained to you was the rivalrous case, so that you have, so that you don't see the where the patch is sitting because you have these crosses all over. The non-rivalrous case was that both stimuli in the two eyes were actually the same, so that you could readily see that there was a square over there. And as you can see, the higher the confidence, the higher the percentage correct for this non-rivalrous case, which is just like the experiment I just showed you. So people are confident, and that then also implies that they have a higher percentage correct. So that's this relation again between confidence and actual performance. However, in the rivalrous case, where you can't see these squares, people still had fairly high percentages correct, something like 70%. But there was no relation with the confidence ratings. And so regardless of confidence rating, the percentage correct sort of stayed the same. There's a slight drop here and a slight drop here as well. But if you then again do this plotting of probability of being correct for different confidence ratings, you get, for the rivalrous situation, you get this more or less diagonal curve indicating a meta d prime of 0, whereas for this situation you get a meta d prime of 3, indicating a very clear relation between confidence rating and percentage correct. So, here people really see these squares, and then there is metacognitive awareness of their performance. Of course, they're not always correct because it's still a bit difficult to see if this is just shown to you briefly. But the important thing is that there is this clear relation between confidence rating and the percentage correct, which is not happening when they are not seeing these things, but nevertheless are having an above chance percentage correct. So meta d prime being 0 there. So indeed arguing that if there's no metacognitive awareness of the performance for the rivalrous stimulus, the performance is hence unconscious. So both global workspace theory and higher order thought theories fall into this same, you could say, same category of theories where there's actually more emphasis on, you could say, higher level processes constituting the neural code of consciousness, and first order representations not so much being important for consciousness. Now, of course, you could argue that, are they actually engaging into the conscious experience itself, or in processes following the conscious experience? Of course, what proponents of higher order thought theory and global workspace theory would argue is that Well, the first order representations, or these lower level subliminal or pre-conscious representations, as they're called in global workspace theory, actually are the precursors of consciousness. So, just like the eye is, it's all nice that you have activity in visual cortex. And maybe even if this is recurrent interactions, and even if this is widespread activity, as long as it's sitting only in sensory cortex, yeah, it's a precursor of consciousness, and it's only really conscious experience if it enters global workspace, or if it enters or if it receives a higher order representation. And of course, they will acknowledge that pushing a button and stuff. Yeah, that's something which will follow that. But regardless, the conscious experience only arises at the moment you have the higher order thought or the global workspace representation. Well, of course, people who would like to critique these techniques would say, oh, no, wait a second. Actually, what you are studying, these processes following conscious experience, you sort of throw out the baby with the bathwater if you say that, what's going on there is unconscious. This is the first order representation is actually sufficient for you to have a conscious representation. And indeed, there are theories which are more in that camp, you could say, arguing that the conscious experience actually precedes these higher order representations, whether they're higher order thoughts or global workspace representations. It's the first order representation which is actually already giving you the conscious experience. So let's have a look at those.